8.7 is on applications of quadratic functions. I'm not going to do much on this, but there aren't very many questions on this on your homework either. But basically, there's, we talk about parabolas because they're quadratics, and quadratics happen when you have gravity, for example, affecting something. And so projectiles are going to be affected by gravity. So here is the height in terms of time. It's -16 t squared plus your velocity times your time plus s, which is the initial height. And so this gets used a lot in physics. And this is done in feet per second. That's where the -16 comes from. It has to do with gravity and feet per second squared. And so here's an example of a projectile. This was really to practice using your calculator with. We type in my on-ground class, we type this into the graphing calculator, and then we use the calculate features, which you guys have practiced at the very beginning of this course for the online class. And then the on-ground class, obviously, we'll do it with the calculator at this point in time. Find when it hits the ground, that's when the y is 0, and so those are finding the zeros. And then you can use the zero calculate feature of your graphing calculator to find a height after 3 seconds. That's when you're giving a value of x. So you can use the value calculate feature of your graphing calculator and say when x is 3, what do you get? 32. What is the maximum height? That means you're looking for the vertex. So you can use the maximum feature of your graphing calculator. Under the calculate, just do maximum and go on either side, and it will find it at 1.5 seconds and 68 feet up in the air. So the height, maximum height part would be 68 feet. And again, these are word problems, these are context, so units of measure are good to include. This next one's a little bit harder to see here because it's not all lovely and colored, but essentially what you'll hopefully recognize is that there's these pairs of points that land in the same place. And so there's a pattern of what the angles are. So here it was 20 and 70 matched up, and here it was the 30 and the 60 that matched up. Here's the 40 and the 50 that matched up. So one of the questions is what would match up with the 80? And so you can see here 10, because then it makes it add up to 90. All of those pairs add up to 90. So it says, if the landing net is placed 104 feet from the cannon, at what angle should it be inclined so that it lands in the net? So 104 is, here's 100, here's 120, so in the middle is 110, and the middle of that is about 105. So you should go roughly 20 or 70 degrees. You might say 19 degrees or 18, and it is a little bit forgiving in the assignment on this. So don't be too nervous about that. B, approximately where do you think he would land if the cannon was inclined at 45 degrees? So 45 degrees would be between the 40 and the 50 parabolas, inclined parabolas here. So what's the maximum height? And you go over to the height, and then you'd say, well, there's 40, there's 50, the height was a little bit under halfway there, so a little under 45, so maybe 42 or maybe 43. It's your best guess as to this. And again, it's approximate. It'll take a few degrees on either side and still give you credit. We already did the one that would go the same distance as the 80, would be 10. They add up to 90. All the pairs add up to 90. The fact that every landing point can come from 2 different paths makes you recognize that the equation is a quadratic, because then you have That's just how quadratics behave. There's two places that will be in the same height, but and land in the same place. That's one of the properties. Okay, and lastly, profit problems are sometimes done. So those are more like projectiles. Now we have business profit is the revenue minus the costs. And if they want to know about the maximum profit, what they're looking for is the vertex of your profit equation. And your profit equation is going to be your equation of the revenue minus the cost one. So don't forget to distribute the negative if the cost has multiple terms. You'll need to subtract each of those terms. They also here give you the formula for revenue. It's the number of items sold times the price, and that's how much you make. But I believe the question has more to do with recognizing that if they want the max profit, if P of X is here, the max is at the vertex. And the profit aspect is the Y coordinate then. It's how many items would get you what maximum profit. The profit is the Y. The X is the number of items that produce that profit. So I hope that helps a little bit with 8.7.